if you want to get started.
Okay, Dick, we can get things started here. And thanks very much, Dick, and to Press for inviting me to speak to the group tonight. It's great to see call signs from all over. I don't think I've spoken to an IRLP group before. I've spoken to a D-Star reflector before, but this is a first for me, and looks like a great. I love to see passionate hands, you know, that say, "Hey, I'm a member of something, and I'm passionate about it," because that's what this hobby is all about. Is the friendships that develop because of the radio. The radio is the vehicle that gets things started, but then now you've got all these new friends, and you know, hopefully we'll be able to get together in person at some of the ham fests and hamvention coming up here next year in Orlando. Maybe it's in Xenia, maybe it's in California. You never know. So again, thanks so much, and we're going to get right into it. We're going to talk about antenna building and antennas tonight, and let me know when you see my slides.
You're on.
Okay, thank you, Dick. And so we're going to just go over a couple of things to remember when you're thinking about antennas and antenna building. I think it's very helpful to go over some of these basics because you know, hey, it was 50 years ago when I started taking amateur radio licenses, and I've been out of college for a while too. So, but an antenna is a really cool device because it converts the RF power coming out of our transmitters into electromagnetic radiation, and it also receives electromagnetic radiation and feeds that to our receivers. And it's very helpful to remind yourself that any conductor through which RF current can be flowing is an antenna, and some of them are unintentional antennas. Another very cool parameter of antennas is the ability to create gain, to create effective radiated power. And feed point impedance is very important, especially these days when we're dealing with solid state amplifiers. Getting 50 ohms is really, really important. And we have to do it over a bandwidth of frequencies, not just one frequency, but if you want to operate on the 40-meter band, you've got 300 kilohertz that you need to deal with. Remember that an antenna properties are the same whether it's used for transmitting or receiving. So if it's a poor transmitting antenna, it's also a poor receiving antenna. Reciprocity exists there. And then knowing that the near field is within a half wavelength of the antenna and the far field is after the half wavelength. And some things on dipoles. Remember that this is a very simple antenna, however, very, very effective, a half wave dipole. And 468 divided by frequency, that's different than a free space half wavelength, which is 492 divided by frequency. And the 468 is the correction factor because the dipole is not in free space. The dipole is over ground, which does alter the length. And it's got a really good self-impedance. It's right around 50 ohms, and it's got some bandwidth to it too, especially if you feed this with 50 ohm coax. Now, if you feed the half wave dipole with open wire, that's thumbs up, because we're going to talk more about that here in a minute. And you can get even more gain by lengthening the dipole about 1 wavelength long, so 2 half waves, and you get a little bit more gain, up to 3.8 dBi, and you still do have some bandwidth. These longer dipoles are a little bit more challenging to match, and that's why it's my favorite antenna is the double extended ZEP, which is 2 5/8 waves in phase, or a total of 1.28 wavelengths. It's got a complicated feed point impedance, But if you feed it with open wire, like 450 or 300 ohm open wire, it's very low loss, even though the SWR is high. That's not the case for coax. Coax loss goes up tremendously when it's got high SWR. That's why the G5RV is not a very good antenna from an efficiency standpoint, because the SWR is sky high and the losses are high. The double extended ZEP has 5 dBi of gain, which is almost 3 dB over a half-wave dipole. You can use a dipole on several bands. It's best to have a half wavelength on the lowest frequency you will use. So if you want to use it on 80 through 10 meters, you want to make sure it's about 128 feet long, fed in the center with open wire the entire way. It's just the low loss transmission line of ladder line is really, really impressive. And here are some takeoff angles and radiation patterns for dipole polarization. And a vertical antenna, there's two parts to a vertical. There is the radiator, the vertical radiator, and then there's the image antenna formed by the ground reflection. And it's very important to have ground radials, even for those verticals that claim they don't need them. If they don't need ground radials, you're going to use your coax, the feed coax, as the other half of the antenna. And so it's very important to improve ground conductivity by having a radial system. And ground radials can be made of any kind of wire. They don't have to be buried. They will bury themselves over time. And the length is not critical, but they should be at least a quarter wavelength long on the lowest frequency you will use. So if you're using like a 43-foot vertical on 80 through 10 meters, you want to make sure that the radials are 66 feet long. That's a quarter wavelength on 80 meters. And here's some of the radial layouts. And a quarter wave monopole is, again, has a self-impedance very close to 50 ohms. So you can feed this directly with 50 ohm coax and do very well. But it does require a ground system, which acts as the return for the ground currents. And you can have short verticals, but their feed point impedance is very challenging because the impedance goes low when the monopole is less than a quarter wavelength long on the frequency of interest. And an inverted L is a very popular antenna for the 160 meter band. You make dimension A as long as you can, maybe it's 35 or 40 feet, and then the remainder is dimension B. The overall length is about 0.3 wavelengths, so about 132 feet or so on 160 meters. And its self-impedance can be pretty close to 50 ohms, and if you need, you can put a series capacitor in series with this to cancel the inductive reactance. You can use a vertical monopole on several bands. And of course, you need to have the matching components right at the base of the vertical for best performance. There's a delta loop antenna, which is about 1 wavelength long, about 100 ohms feed point impedance, and can be easily matched to 50 ohm coax by using a quarter wavelength of 75 ohm cable. Depending upon where you feed the loop is where vertical or horizontal polarization is taken into account. And so if you feed the square quad-like element on the side, that's vertical polarization. If you feed it on the bottom part of the element, that's horizontal polarization. Yagi's very impressive. The Yagi array with its driven element, and then parasitics, reflector, and maybe a director 2 or 3. And here's the 3-element Yagi with the reflector, a driven element, the director. And typical Yagis for 6 and 10 meters. The 6-meter Yagi is a folded dipole driven element, and the 3-element Yagi is matched with a gamma match to get the 50 ohm point on the driven element. You can have a 2-element Yagi that may be a reflector or a director for that second element. And there are trade-offs. Designs that have a reflector have lower gain, poor front to back, but they have a higher feed point impedance. Designs using a director have higher gain, good front to back, but a low feed point impedance. So there are trade-offs. The 3-element Yagi gets you about 8 dBi or 6 dB over a dipole. You can tweak to have good front to back, good gain, and a decent feed point impedance. You can have more than 3 elements, and by adding additional directors, and there's great Yagi designs found in the ARRL antenna book. Here is an M² Yagi. This is a beta match, and you see that the beta match is attached to the boom. There is also a coax ugly balun. It's ugly for 2 reasons. It's ugly because it looks ugly. It's ugly because it doesn't work very well at all. It has very low common mode impedance, and these were popular maybe 25 or 30 years ago, but I would not recommend using a coil of coax as a choke today at the feed point of a Yagi. And you can use ring rotators to rotate antennas around the face of a tower. That makes use of the side of the tower. This is the 20-meter tower here at K3LR with multiple stacked Yagis on ring rotators. And to insulate elements from the boom, this is a piece of garolite. This is a 15-meter element at the end of the boom. Another popular antenna is the Moxon rectangle. And this is a 2-element Yagi where it's a reflector-driven element. The input impedance is 50 ohms, which is really great. The gain is pretty good. It's about 4 dB better than a dipole. It's got great front-to-back ratio. I'm actually using Moxons here on 40 meters for the second station on 40, and they work quite well. A little ground plane antenna can be built just out of an SO239 with sloping radials. The sloping ground plane wires, the slope makes the feed point impedance go from about 36 ohms up to 50 ohms instead of having the traditional 90 degrees between the ground plane wires and the driven element. Here's a BNC connector for 470 centimeters for 440. And again, over on figure A is a traditional quarter wave vertical radiator with the quarter wave ground plane rods. That's going to give you about 36 ohms. But in figure B, if you take and slant them down, you get a better match to 50 ohms. And a 4-element Yagi, 2 directors, a driven element, and a reflector. And then if you want to get additional gain, one way to get 3 dB of gain is to take an identical Yagi, space it a half wavelength apart. And here is an 8-element 10-meter antenna here at K3LR. And this Yagi has a single reflector, the driven element, and then 6 directors to it on a 50-foot boom. And notice that first director is very tightly coupled. That is known as an optimized wideband antenna, or OWA. And what that does is that drives the feed point impedance to 50 ohms, and it stays at 50 ohms across a large percentage of the band. In this case, the SWR never gets greater than 1.2 to 1 for 1 megahertz. For 1,000 kilohertz, it stays under 1.2 to 1. Another shot of the OWA design: reflector on the left, driven element in the center, first director very close to the driven element, causing the feed point impedance to stay at 50 ohms. And the coax going up to the driven element. To get more gain, it's about stacking. So there's one of those 8-element Yagis on the top of the tower, and that's got about 14 dB of gain on its own. Then you add the second one, you come down 33 feet, add the second one, and now you get 17 dB of gain. To double that, to get 3 dB more or double the power, you need to add 2 more Yagis, which gets you to 20 dB of gain. So that's how the gain increases with the number of Yagis. And when building antennas, I like to make sure that all of the aluminum oxide that is on the aluminum is all cleaned off, and making sure you go inside of the elements as well as outside. Once you get the the aluminum oxide cleaned off, you want to use an antioxidant such as Jet Lube SS30. W3LPL told me about this almost 30 years ago, and I've been using it ever since. I do not use Penetrox. SS30 is really good for putting antenna elements together, and it keeps them clean and working well for many, many years. And SS30 is available at DX Engineering. And once you get the antenna element clean, you put on the SS30, and these are elements getting ready to go into other pieces of the antenna element. And then I use cross pins by drilling and then inserting stainless steel hardware with external tooth lock washers. Here you can see these are the 4th director. This is on a 15-meter Yagi, and you can see the center pieces. And here are the driven elements. Again, with the OWA, you don't have to have a gamma match, a beta match, a T match. It's a direct feed, just like a dipole, and it's really, really good. And so using fiberglass in there, another shot of the fiberglass. And here is one of the 2-element 40-meter Moxons, and we're getting ready to put the T elements on it. And you can see over on the left-hand side, that's the driven element, and the choke, which is number 40, number 31 beads, is mounted on standoffs about 3 inches off the boom to preserve the CMI. And then the RG213 comes up to the feed point connector. That's a DX Engineering FPC. And then that allows a very waterproof, weatherproof transition between the SO239, the coax, and the driven element. And you can see there's 2 leads there, the red lead and the black lead. And the red lead goes to the center conductor, the black lead goes to the shield. And we always mark where the red is connected. If you're standing on the tower K3LR, all of the center conductors of the coax are on the right, which is known as right on red. And the center of a boom on 10 meters with the overhead boom truss. This is a piece of 2-inch OD aluminum on a DX Engineering plate. And you can see one of the directors, the insulator for the director. And we level up all of the elements on using the G10 epoxy plate. Notice the orange SS30 on all the hardware. It also acts as an anti-seize, which is very important for stainless hardware. And you can see the various element plates on the boom. And you can see we take the aluminum oxide even off of the areas where we're going to use the U-bolts. These are DX Engineering saddle clamps, the 300Bs, and getting everything level. This is the end of the boom. This is the only place I use end caps, is on the boom. You want to leave the elements open, let the water out. And it's very important on the end cap that you cut a hole that allows the water to come out, because water will get in. There's no way to seal that off with all the air inside that boom. So it's very important to have a hole cut so that water can get out. And here's the overhead boom riser for the boom truss. You can see the Philly strand truss overhead now, holding up the end of the boom. And here's the turnbuckles to make sure that we get the exact amount of lift. And this is the attachment of the turnbuckles to the boom riser. Again, a DX Engineering plate. And here's the overhead boom truss, the Philly strand coming down to the eye bolt that goes through the boom. Another shot of the overhead boom truss. The elements are now mounted on the boom. Everything was leveled. And so what you get is all of the elements are perfectly level. This is the 40 number 31 beads and heat shrink, and then Scotch 88 tape on top of the heat shrink. RG213 coax from DX Engineering. Here's the end of the DX Engineering coax going to the Amphenol 83 1SP connector, and using the DX Engineering installation of with the heat shrink over the back of the coax. And this is where the driven element will mount. Notice the SS30 there. Here's the driven element in place. And now with the DX Engineering feed point connector hooked right to the feed point of the 10-meter Yagi. And here are the standoffs of the choke. Standoffs in place. And that is my presentation this evening, and I am available for any questions you might have. I was wrong, Dick. It took 21 minutes.
How do I mount something like that on my truck?
Well, you make sure your truck's not moving.
Very impressive. Excellent.
What do you use to turn such a heavy antenna like that on your tower?
Well, actually, I'm using a prop pitch or the ring rotators, but I do have a prop pitch that turns the top antennas here. But DX Engineering has finished design and testing of a new rotator, which will be available for sale starting in the second quarter of 2022, which will turn an antenna like that, and even a smaller antenna very reliably.
Tim, I've got a question. It's KE7K.
Yes.
Thank you for doing this, first of all. I know everybody enjoyed it. I think it was the slide of the 15-meter antenna. It looked like you had used progressively smaller aluminum going out. How did you decide when to transfer from one ID to the next?
So we have a program that we sell at DX Engineering called Yagi Mechanical. And what I do is I like to look at the ARL antenna book. They have suggested tapers
Okay.
of aluminum, and then you can put those into Yagi Mechanical and make sure that the element is strong enough to withstand the wind in your area.
Okay, gotcha. All right, well, I've got an antenna buck. I just hadn't come across that before, so thank you very much.
They have the tapers in there, and that's a great place to start.
Great, thank you.
Tim, Press here. I had a question for you. You mentioned anti-seize, and you mentioned that stainless has a problem with that. I never realized that. So I'm on a coastal area, and I'm planning on putting up. Well, I have an aluminum tower and pole style tower, and then I want to have like a cross brace and stuff, and a lot of that's going to be aluminum. But I wanted to maybe use some bolts with nylox. I was thinking stainless with nylox because of wind and whatever. But are you saying that that's a bit of a danger in terms of seizing and in terms of strength?
It is a problem if you don't use anti-seize. You will gull that stainless. So you have to use anti-seize, and SS30 is a very good anti-seize for that press. But if you look on the DX Engineering website about stainless steel hardware, and I use lots of it here. I've got 50 antennas here, so I use tons of stainless. But you must use anti-seize on stainless, otherwise it will gall, and you'll have to break it.
Could you describe the word gall? Spell it.
All is because stainless is somewhat soft. What happens is as you start to put that nut on and you're cranking away with your ratchet, you're actually creating heat. And if there's not a lubricant there, it will distort the threads and it will lock up.
SS30 is my friend then. Okay.
SS30, don't leave home without it. The problem with SS30 is when you open this can, it seems to get on everything. We've got a cat around here that has SS30 on its tail, but we're well grounded, we're well greased up, and there's not going to be any oxidation here.
Tim, I'd like to, it's Dick again, JPQ. That's not a green screen behind you, is it?
No, it's not. That's the real deal, Dick.
Wow.
Well, one of Tim's talks is the K3LR story, and we have yet to pick our December topic. Tim's coming back in early December, I believe. So we'll put the poll back up, but I have seen some of this station remotely, and it is breathtaking. So that would be my vote is the next topic, but that's up to you guys.
Press, I can tell you that the K3LR talk, which is one of the most popular talks, it lasts about 33 minutes. It's 160 slides, and I suggest seatbelts because it is just unbelievable.
Guys, if you've driven on I-80 through Pennsylvania near Ohio on the way to Dayton, this is this crazy guy's station that you can see that looks like the Voice of America. How many towers are there visible from 80, Tim?
13.
13. And you drive by this thing and you just go, oh my goodness. And the goodies that are inside the barn are, like I said, breathtaking.
Other questions?
Well, I guess I'll ask one if we don't have any. What would you suggest to a new ham or a young ham starting out, wants to get on low bands, maybe doesn't have a lot of, maybe not a lot of real estate or certainly not a lot of coin, somebody getting started. What's the most bang for the buck to get on the low bands?
So, we get asked that question a lot, Press, and we've done a lot of research in that area. One of the fastest, easiest, least expensive ways to get on 20, 40, and even 80 meters is with the Hustler vertical. The Hustler verticals have been around for 60 years. And the same design that was designed 60 years ago is still being made today by the people that own the Hustler antenna company. And we sell lots of them, and they're very inexpensive and they really work. I mean, you can put them in the backyard. The more radials you have down, better they work. But even if you don't have a lot of radials, they're going to work really well. And so, that is probably the most effective way. Or if you can find a used Hustler vertical or a used butternut vertical, that can work well. Like I said, a dipole that is fed with open wire the entire way, that is at least a half wavelength long on the lowest frequency. So one of my favorite antennas is what we use on field day all the time, 130 feet of wire fed in the middle with open wire the whole way to an open wire tuner. Man, it's magic. And that's not very expensive.
Well, Tim, there's a new ham in here that's got a big smile on his face. Roger, K04QMM, sitting down there, and he's got one of these verticals that you talk about, and he's a new ham. And I got to tell you, Tim, he's lighting the world on fire. His enthusiasm is so good. He's got 1,000 feet of ground radials in, and I don't know, Roger, if you got any questions, but it is really working for you.
Oh, I love it. Do you hear me?
Oh, yes, Roger.
Because I got earplugs in. I don't know if this thing worked or not. But yeah, I love it. I just got done talking to Iceland probably an hour ago, and I love it. I mean, it just gets better and better. I've gotten 37 countries now, and I just got my general July, or I think July 21st.
Well, congratulations, Roger. What was the Tango Fox call sign of the Iceland station?
Oh, I have no idea. I'm in my living room right now. I am not that good yet. Jeez.
Would another 1,000 feet of ground routes help him, or ground radios help him? We've been kidding him because he's been putting ground radios out all summer.
Well, you know, I love to put radials out. I've got tons of them here. But Roger, congratulations on getting your general. Great job on the DXCC count. You're going to be at 100 before you know it. And enjoy the ride, because you're going to make some really good friends in this hobby. This is the best hobby to make friends with, and we all are cheering you on and want to help you.
Well, thank you. Thank you for all the help too. You have helped, and from the very beginning, because you had a package, something that somebody like me could go for right away for. And I wanted to talk to people across the world, you know, antenna to antenna. So that's what I pushed for. And I met these guys in the Zoom room off the East Coast Reflector, and they helped me tremendously. And here I am, and I love it. I look forward to it all the time.
Now
You're
Roger
living the
talks
dream,
about
Roger.
barefoot and all knobs to the right. And a couple of months ago, he didn't even know how to spell radio.
It's working, Roger. That's great.
Yep. Thank you again. I'm glad you guys were there. You helped out a lot.
When you were talking to Iceland, did you find out whether or not they serve ice cream up there?
No, I didn't. I was probably going to the next call.
This is Joe, K3LR. Now that we're talking to the man of HF, you're bringing up the you guys not liking the G5RV. Well, I have one.
Well, yeah, Joe, it's a good start. I just want you to know the limitations of it, and that there are better antennas out there. The G5RV is very popular because people believe that it's a multi-band antenna. It's a multi-band antenna with a tuner, and it's got coax in it. And so, Joe, I just want you to know that because you've got coax in the feed system of a very high SWR antenna, it's not going to work as well as if you were to make it 130 feet long and feed it with open wire. It's going to work night and day better.
Okay. So, you said what? Wire with open
wire.
Open wire?
Yeah.
Okay.
Ladder line.
Yeah, that's also the thing. The G5RV has ladder line.
It does have some ladder line, but it has some coax, right, Joe?
Just to the end of the plug where you plug in the feed line to your to my radio. I have about 50 feet feed line.
See, that's where the problem is, Joe. That 50 feet of coax, when the SWR is high, which it is everywhere with a G5RV, that's loss.
Okay.
That means your power is going up in heat, and it also affects your ability to receive. But the good news is, Joe, there's life after the G5RV, and life gets better, and you can hear more stations, and more stations will hear you, especially on 40 and 80 meters. So if you can swing it, try to get up a half-wave dipole on 80 meters with ladder line. And if you have any questions, the team at DX Engineering, they know all about this, because we talk about this a lot, and they're very experienced hams. The G5RV is a good starting block, but that 50 feet of coax, Joe, is probably costing you 2 or 3 S units.
Okay. I'll take a look at it and talk to the guys and see what if they understand this more than I
Hey.
do.
Listen, Joe, we all had to learn this stuff.
Yeah,
And everything I know, I learned from somebody else.
right.
You know, and hams always will help hams. And when I was getting started in this 50 years ago, I mean, I must have wore out these Elmers because I was asking questions like crazy. So always ask questions and always want to learn, and you'll get better and better and better, and you'll be stronger and stronger, and you'll have more fun. You'll meet more people.
Yes. Thank you very much. Yeah, I've been with the East Coast Reflector guys for a little over a year, so I know these guys very well, and I know they will help.
It's a great group of guys here.
Yes, they are.
Well, as the guy who kind of invited you, I'd like to express my thanks. I've seen your talks on the Great South Bay a number of times. I know the club here in Long Island is a lot of fanboys of Tim, and now I think we've brought this to the East Coast Reflector. We're looking forward to our next one. So I just wanted to express my thanks, Tim, and much appreciated.
Well, thank you very much, Press, and to all of you that are here tonight on Zoom and the East Coast Reflector. It's been a real pleasure to talk to you. To those of you who are DX Engineering customers, thank you so much for your business. For those of you who are not yet, give us a try. I think you'll be pleasantly surprised how well things will go. We really do go the extra mile. We bend over backwards, and we're going to do everything we can to help you have more fun with the best hobby in the world.
Well, thank you, Tim.
Don't be a stranger, Tim. Hang out here in Zoom room or get on East Coast Reflector and say hello now and again too.
I will, Press. Thanks so much. I'm off to another club meeting.
For all of us at the East Coast Reflector, thank you, Tim. And for the rest of the guys, we're here all the time. This meeting runs 24/7. People come and go all the time. We have a lot of new faces here, but come in, join us anytime. We're here. Somebody's usually here all the time. So it's not a meeting that's from 8 to 9 tonight. It's 24/7, 365.
Thank you, Tim.
73,
Thanks,
Dick.
Tim.
73, Press. See you guys later.
Thank you.
Thank you, Press.
Thank you.
That was fun.
Yeah.
Looks like we did a good job. We had 51 participants.
50.